Welcome everyone. In this video, we are still focusing on hypothesis testing, chi-square test. Hypothesis testing, chi-square test. Now, in our previous video, we started with hypothesis testing, chi-square testing, and then we started working out an example. We were able to do just one example. Now, in this video, we will look at two more examples to help you improve in terms of understanding and also for you to be able to practice. Now, let's look at our second question. And this is a part 2 of the chi-square test. Now, a public health officer wants to find out whether exercise habits is related to blood pressure status among adults. The data collected are shown below. A public health officer wants to find out whether exercise habits is related to blood pressure status among adults. The data collected are shown below. So we have those who exercise regularly. This is how we interpret the table. And now in chi-square test, this table that will be given to you in the question, we call it the observed frequency table. This table that would always be given to you in the question, we call it the observed frequency table. Now, from the table, those who exercise regularly, 18 of them have high blood pressure. Those who exercise regularly, 22 of them have normal blood pressure. And the total number of people who exercise is 18 plus 22, that is equal to 40. Now, those who do not exercise regularly, 22 of them have high blood pressure. Those who do not exercise regularly, 18 of them have normal blood pressure. Okay, this is how we interpret the table. So, those who exercise regularly with high blood pressure, 18. Those who exercise regularly with normal blood pressure, 22. Those who do not exercise with high blood pressure, 22. Those who do not exercise with normal blood pressure, 18. Now, if you want to know the total number of people who exercise regularly, you use this row. So, it's 18 plus 22, that is 40. If you want to know those who do not exercise regularly, their total number is this row, 22 plus 18, that is equal to 40. If you want to know the total number of people with high blood pressure, that is this column. So 18 plus 22, that is 40. If you want to know the total number of people with normal blood pressure, is this column, 22 plus 18, that is equal to 40. Now remember, this type of table in chi-square testing, we call it a 2 by 2 table. This type of table that you are seeing, we call it a 2 by 2 table in statistics. Now, why is it a 2 by 2 table? Here, don't count this. 2 by 2 means that 2 rows and 2 columns. Now, the 2 rows, this is not part of the columns. This is also not counted as part of the rows. This is also not counted. The total portion is also, this total is also not counted as part of the column. Now, the rows, this total is also not counted as part of the. So we use this and this. So we have 2 rows, 1, 2, and we have 2 columns, 1, 2. So we call this a 2 by 2 table. 2 by 2. So 1, 2, 2 rows, 1, 2, 2 columns. So this kind of table, we call it a 2 by 2 table. Okay. We count the rows, we use where we have the frequencies, not where we have the totals and where we've written the variables. That area is not counted. Where we have the frequencies is the only place we count. So we have 2 rows, 1, 2, 2 columns, 1, 2. Okay, let's assume we were having 3 rows, 1, 2, and another, category. Then we would have had 3 rows. And we can have a 3 by 2 row in chi-square test. You can also have a 2 by 3 row. I'll show you all those examples for you to see as we moved on. Okay, good. So this kind of table, this type of table, we call it a 2 by 2 table in chi-square testing. Okay, now the question goes further to say that test at 5% level of significance whether exercise habit is related to blood pressure status. Test at 5% level of significance whether exercise habit is related to blood pressure status. Now, this level of significance, so the level of significance you'll be working with at 5%. Now, the level of significance would always be given to you in the question. the level of significance would always be given to you in the question. Remember that in a situation where they don't even state the level of significance in the question, the common significance level we use in chi-square testing is 5% level of significance. But the level of significance would always be given to you in a question. Now, there are times they won't write test at 5% significant level. They can tell you test at 95% confidence level. That is the same. When we say 95% confidence level, is the same as 5% significance level. Now, this 5% significant level is the same as 5 over 100. And 5 over 100 is 0.05. This 5% level of significance is the same as 5 over 100. And 5 over 100 is the same as 0.05. Now, in statistics, the significant level is what we also call the alpha level. Put that in mind. Now, let's start with the solution. Now, for the analysis, in chi-square testing, the first thing to do is to state the hypothesis. The first thing to do is to state the hypothesis. Remember, in stating the hypothesis, we don't state only one hypothesis. You state two. One is the null hypothesis. The second is the alternative hypothesis. Now, you don't need to always write null hypothesis and write into brackets H naught, the H subscript 0. You can just write H subscript 0 without writing the null hypothesis. It's accepted. The alternative hypothesis, you can either write H1 or HA. It's also accepted. Okay, so remember, the first step is you state your hypothesis. Two hypotheses, the null hypothesis and then the alternative hypothesis. How do you state the hypothesis? You come back to the question and look at the variables that you have in the question. A public health officer wants to find out whether exercise habit is related to what? Blood pressure. So we have two variables, exercise habits and blood pressure. So in stating the hypothesis, come back to the question and identify the variables. Here we have exercise habits and blood pressure. So the null hypothesis, you are just going to write, there is no relationship between exercise habits and blood pressure status. Then the alternative hypothesis, you just write, there is a relationship between exercise habits and blood pressure status. Simple as that. So in stating the hypothesis, you come back to the question and identify the two variables. They would always give you two variables in the question. You can even see that from the table. See, from the table, we have exercise status and we have blood pressure status. Okay, good. So in stating the hypothesis, you just write the first one, the null hypothesis. You write there is no relationship between exercise habits and blood pressure status. Then the alternative hypothesis, you write there is a relationship between exercise habits and blood pressure status. So you see the null hypothesis, this is the underlying word. The moment this is missing, is wrong. No relationship. No relationship. So anytime we write any hypothesis and within the hypothesis, we make a statement that there is no relationship, that hypothesis is null hypothesis. When we write a hypothesis and we state that there is a relationship, such a hypothesis is alternative hypothesis. And they can ask you that in exams. They can write a hypothesis and ask you, what kind of hypothesis is this? Now, if you want to know whether it's a null hypothesis, just look for no relationship. Sometimes they will use no effect or no difference, but commonly in statistics, we use no relationship. Now, if you want to know whether the hypothesis is alternative, look for there is a relationship. Okay, so the first thing to do, the first step is you state the hypothesis, the null hypothesis, the alternative hypothesis. Now, step two, you choose the level of significance. You choose the level of significance. And that has already been given in the question. Test at 5% level of significance. Test at 5% level of significance. So you come over here and you write, choose the level of significance. Alpha is equal to 0.05. You remember I told you that the alpha is the same as the significant level. So if they tell you the significant level is 5%, 5% is the same as 0.05. So it means alpha is equal to 0.05. Then you write. If, for example, here was 2%, all it means is that alpha will be 0.02. So if they tell you it's 2%, meaning the confidence level is 98% confident level, and that is 2/100, okay, then you write it over here. But here it's 5%, so it's 0.05. Now, the step 3, calculate the expected frequencies. The step 3, calculate the expected frequencies. Now, the formula for calculating the expected frequency is equal to row total multiplied by column total divided by grand total. The formula for calculating the expected frequency, E is equal to row total multiplied by column total divided by grand total. The formula for calculating expected frequencies, E is equal to row total multiplied by column total divided by grand total. Now, someone will ask that, why are we calculating expected frequencies? Now, in calculating the expected frequency, you are coming to use the observed frequency table to calculate the expected frequency. Now, the reason why we are calculating this expected frequency is that we want to have an idea how these frequencies over here, how they will look like if there was actually no relationship between the variables. How would the frequencies look like if there was actually no relationship between the two variables, the exercise habits and the blood pressure status? How would these frequencies look like? These frequencies, if there was actually no relationship between the variables, how would the frequencies look like? That is the reason why we calculate the expected frequencies. Okay, so you calculate the expected frequency for this, the expected frequency for this, the expected frequency for this, and the expected frequency for this. So you have to draw another table. On that table, the only difference is that on that table, you won't show the totals. You won't show the totals. You won't show the row totals, and you won't show the column totals. This is called the row total, and this is called the column total. On that table, you won't show the row total, and you won't show the column total. You are just going to show this part of the table. 1, 2, 3, 1, 2, 3. Just this part of the table. So you come and draw the table here, and that table is called the expected frequency table. The expected frequency table. So you are going to calculate the expected frequency for this 18, the expected frequency for this 22, the expected frequency for this 22, the expected frequency for this 18. So we want to know, how will this 18 look like? This 18 you are seeing over here is an 18 that there can be a possibility that the null hypothesis is true or the null hypothesis is not true. But how would this 18 look like if there was actually no relationship? That's the essence of doing the expected frequencies. Okay, so if you want to know the expected frequency for this 18, the formula says the row total, this is the row total for the 18. If you trace the total, is 40. And this is the column total, is also 40. The formula says multiply this 40 by this 40 and divide by the grand total, 80. That is what has been done over here. 40 by 40 divided by 80. And that is the formula. Row total multiplied by column total divided by grand total. And that is what has been done. So if you want to know the expected frequency for this 18, is row total is 40. The column total is 40. So you multiply this 40 by this 40, then you divide by 80. So 40 multiplied by 40 divided by 80, that is 20. Then you come to this 22. If you want to know the expected frequency for this 22, is the row total. The row total is 40, is still 40. Then the column total, trace down here. The column total is also 40. The formula says multiply this 40 by this 40 and divide by 80. And that is what has been done. That is what has been done over here. If you come over here, that is what has been done. That is what has been done over here. So 40 multiplied by 40 divided by 80, that is equal to 20. Okay, good. Then you come back to this portion. You come back here. Okay, you come back here. So when you come over here, we are coming to calculate the expected frequency for 22. The same thing. Check the row total is 40. Check the column total. Trace down is also 40. The formula says multiply this row total by the column total and divide by the grand total. This is the grand total. The number you have over here is always the grand total. So multiply this 40 by this 40 and divide by the 80. And if you come over here, that is what has been done. 40 multiplied by 40 divided by what? 80. That is 20. Then you come back over here. We are coming to calculate the expected frequency for the 18. Check the row total 40. Check the column total 40. The formula says row total multiplied by the column total divided by the grand total 80. So 40 multiplied by 40 divided by 80. That is what has been done over here, 20. So the expected frequencies will be 20, 20, 20, 20. So the expected frequency is 20 for all. So now we have two tables. This is the observed frequency table, and this is the expected frequency table. This table is the observed frequency table, and this table is the expected frequency table. Okay, good. Then you move on to step 4. Step 4 says that compute the chi-square statistic. Compute the chi-square test statistic. Compute the chi-square test statistics. How do you compute the chi-square test statistics? There is a formula for doing that. The formula states that S squared is equal to summation of into brackets observed minus expected, close the bracket, all squared, all over expected. Chi-square calculated, we call this, you are seeing over here, we call it calculated chi-square. Calculated chi-square is equal to summation of into bracket observed minus expected, close the bracket, all squared, all over expected. This symbol you are seeing over here, we call it calculated chi-square or computed chi-square. The formula is equal to summation of observed minus expected, close the bracket, all squared, all over expected. Now, you come and draw another table. On that table, we want to show these frequencies, the frequencies in the observed frequency table and the frequencies in the expected frequency table. Okay, so you are coming to draw another table. Now, on the table, you write out all the categories in this observed frequency table. Now, if you understand this table very well, you will notice that there are 4 categories. Let me explain to you very well. Pay attention over here. Now, look, exercise, those who exercise regularly with high blood pressure is category 1. Those who exercise regularly with normal blood pressure is category 2. Those who do not exercise regularly with high blood pressure is category 3. Those who do not exercise regularly with normal blood pressure is category 4. So this table is actually showing 4 categories, 4 different frequencies. Now, the same thing applies to if you come to the expected frequency table. Those who exercise regularly with high blood pressure, category 1. Those who exercise regularly with normal blood pressure, category 2. Those who do not exercise with high blood pressure, category 3. Those who do not exercise with normal blood pressure, category 4. Okay, so you are going to show all these categories. This time, we want you to draw the table in a different way and write out all the 4 categories this way. So, exercise regularly with high blood pressure, category 1. Exercise regularly with normal blood pressure, category 2. Do not exercise regularly with high blood pressure, category 3. Do not exercise regularly with normal blood pressure, category 4. So, you see, we have 4 different categories over here. Exercise regularly with high blood pressure, category 1. Exercise regularly with normal blood pressure, category 2. Do not exercise regularly with high blood pressure, category 3. Do not exercise regularly with normal blood pressure, category 4. Then we want you to show the observed frequency. So on that table, you show all the 4 categories. Then you write the observed frequencies. Then you write the expected frequencies. Okay, then you create another column over here and write the formula. So observe, there's the formula. Observe minus expected, close the bracket, all squared divided by expected is the same as this formula. Okay, good. So this observe you are seeing over here is what is in the table that was given to you in the question. This table, the observed frequency table. So the O you are seeing over here is the frequencies that were given to you in the question. So exercise regularly with high blood pressure, 18. Here is it. Exercise regularly, high blood pressure, 18. Exercise regularly, normal blood pressure, 22. Here is it. Exercise regularly, normal blood pressure, 22. if you come over here to do not exercise regularly, high blood pressure, 22. Here is it. Do not exercise regularly, high blood pressure, 22. Okay, then here is the do not exercise regularly, normal blood pressure, 18. Here is it. Do not exercise regularly, normal blood pressure, 18. Then this expected frequency is showing the frequencies in the expected frequency table. Exercise regularly, high blood pressure, 40. Here is it. Exercise regularly, high blood pressure, 20. Here is it. So you see, exercise regularly, high blood pressure, 20. Exercise regularly, high blood pressure for the expected, 20. If you come over here, exercise regularly, normal blood pressure for the expected, 20. Here is it. Exercise regularly, normal blood pressure for the expected, 20. Do not exercise regularly, high blood pressure, 22. For the observed, we've done that already. Do not exercise regularly, high blood pressure, 20. Here is it. Do not exercise regularly, high blood pressure, 20. And do not exercise regularly, normal blood pressure is also 20. Here is it. Do you get it? Good. And that is how we were able to do this table. Then you create another column. On that column, you write the formula there. So you are coming to interpolate these frequencies. You are coming to put in these frequencies or put these frequencies for the observed and expected for each category into the formula and calculate the calculated chi-square. Okay, so you are coming to interpolate that into the formula. So when you take for category 1, the observed is 18, expected is 20. Then you interpolate the frequency into the formula. It says observed minus expected, close the bracket, all squared divided by expected. So the category 1, exercise regularly, high blood pressure, observed frequency is 18, expected frequency is 20. When you interpolate into the formula, observed is 18 minus expected is 20, close the brackets, all squared, all over the expected is 20. That will give us 0.20. Then you come to exercise regularly, normal blood pressure, observed is 22, expected is 20. You interpolate into the formula. So the formula says observed minus expected, all squared. Observed is 22. Expected is minus 20. Close the bracket, all squared, all over the 20. That is the expected. That will give you the same 0.20. Then you come to do not exercise regularly with high blood pressure. The observed frequency was 22. The expected frequency was 20. So the formula says observed minus expected, close the bracket, all squared, all over expected. So observed is 22 minus expected is 20. Close the bracket, raise the power 2, all over 20. When you compute, you get 0.20. Now, do not exercise regularly with normal blood pressure. Observed is 18. Expected is 20. You interpolate this into the formula. You get 18 minus 20. Close the bracket, all squared, all over 20. That will give you 0.20. Then now, when you finish, you sum up, because the formula says summation of observed minus expected, close the bracket, all squared, all over expected. So you sum up the calculated chi-square for all the categories. So 0.2 plus 0.20 plus 0.20 plus 0.20. That is what has been done over here. So the calculated chi-square is equal to 0.20 plus 0.20 plus 0.20 plus 0.20. That will give us 0.80. So the calculated chi-square is equal to 0.20 plus 0.20 plus 0.20 plus 0.20 plus 0.20. Okay, and that will give us 0.80. Okay, so the calculated chi-square for all the categories is 0.80. Now, step 5, you determine the degrees of freedom. In step 5, you determine the degrees of freedom. Now, what is the formula? In chi-square test, you remember that in confidence interval, degree of freedom, df is equal to n minus 1. In chi-square test, the formula is different. In chi-square test, the df is equal to, into bracket, r minus 1, close the bracket, open the bracket, c minus 1, where r is equal to row number or number of rows, and c is equal to number of columns. Now, you remember that in a 2 by 2 table like this, we have 2 rows and 2 columns. See, row 1, row 2. How many columns? 2 columns. Column 1, column 2. Column 1, column 2. Row 1, row 2. Column 1, column 2. Row 1, row 2. You can have a table where you have 3 rows and then 2 columns. You can also have a table where you have 2 rows and 3 columns. Okay, so take note of that. So here we have 2 rows, 2 columns. So you come and put that into the formula for the DF. So DF is equal to R minus 1, close the bracket, C minus 1. So R is 2 and C is 2. So you put that into the formula. In the end, you get 1. But remember, there is a shortcut. Anytime you have a 2 by 2 table, the DF is automatically equal to 1. Anytime you have a 2 by 2 table, the DF is automatically equal to 1. Anytime you have a 2 by 2 table, the DF is automatically equal to 1. Anytime you have a 2 by 2 table, the DF is automatically equal to 1. Anytime you have a 2 by 3 table, the DF is automatically equal to 2. Anytime you have a 2 by 3 table or a 3 by 2 table, the DF is automatically equal to 2. In this situation, we have a 2 by 2 table, DF is automatically equal to 1. Just learn that shortcut. So when you have a 2 by 2 table, DF is automatically equal to 1. When you have a 2 by 3 table or a 3 by 2 table, DF is automatically equal to 2. Learn this shortcut. So in step 5, you determine the degrees of freedom using the formula. Step 6, you find the critical value. Step 6, you find the critical value. Now, step 6, you need step 5 and step 2 in order to get step 6. Okay, step 2 is where you chose the significant level, and the significant level is 0.05. Step 5 is where you determine the degree of freedom, which is equal to 1. Step 6, you need step 2 and step 5. So step 6, you find the critical value. In finding the critical value, you are going to use the chi-square distribution table, but you need the DF. In this situation is 1. And then the alpha level in this calculation is 0.05. So you go to the chi-square distribution table. When you come to the chi-square distribution table, look for DF1. So DF1 is here. And look for significant level 0.05. So you see DF is 1, significant level is 0.05. When you trace, the critical value is 3.841. So DF is 1, critical significant level is 0.05. When you trace, the critical value is 8.41. And that is what has been written over here. So the chi-square critical value. So this one, we call it the chi-square critical value. Is 3.84. So you notice that here is called the calculated chi-square. The calculated. When you are doing the step 4, you are doing the calculated chi-square. That is equal to 0.80. But when you come to the step 6, you are doing the chi-square critical value. That is where you use the DF and then the alpha. So the chi-square critical value is 3.84. The chi-square critical value is 3.84. The chi-square critical value is 3.84. Is that okay? Great. How did you get the 3.84? DF is 1. Alpha is 0.05. You come to the chi-square distribution table. DF is 1. Level of significance is 0.05. DF is 1. Level of significance is 0.05. In a situation where you have degree of freedom 1, level of significance 0.05, you see the critical value is 3.84. Okay, then you come and write that over here. So x squared critical is equal to 3.84. Then step 7, you state your decision rule. Step 7 is where you state your decision rule. We have 2 decision rules in hypothesis testing, especially chi-square test. There are 2 decision rules. You have to state the decision rule. The same as has been written here. You just have to memorize it. Now, if you do the calculation without stating the decision rule, it's wrong. You have to state the 2 decision rule. Now, the first decision is that if the calculated chi-square is greater than the critical value, you reject the null hypothesis. If the calculated chi-square, this is the calculated chi-square. If the calculated chi-square, the answer is greater than the critical value, this is the critical value. So if this is greater than this, you reject the null hypothesis. Okay. Now, the second decision rule is If the R squared, the calculated R squared, is less than or equal to the critical value, you fail to reject the null hypothesis. Okay, so you can tell from the decision rule that the condition is always on the null hypothesis. The focus is always on the null hypothesis, or the decision is always centered on the null hypothesis. Okay, so see, if the calculated R squared is greater than the critical value, reject the null hypothesis. Okay, this is the calculated R squared, or the computed R squared, and this is the critical value. If this one is greater than this, reject the null hypothesis that you stated over here. Reject it. Let me go over it again. If the calculated R squared, the calculated R squared that you do in the step 4, if it is greater than this, the critical value, the decision rule says that reject this null hypothesis. Okay, that is it. Now, the second decision rule states that if the calculated R squared is less than or equal to the critical value, fail to reject the null hypothesis. So this one, if the calculated R squared is less than the critical value, you fail to reject the null hypothesis. Now, you notice that, okay, look at the first decision rule. If the calculated R squared is greater than the critical value, reject the null hypothesis. Now, listen, you rejecting the null hypothesis is more like you are accepting the alternative hypothesis. But in statistics, we do not want you to say that you've accepted the alternative hypothesis in statistics. We don't write that statement. Okay, so you look at it. If the calculated R squared is greater than the critical value, reject the null hypothesis. There are two hypotheses involved. So if you are rejecting the null hypothesis, automatically you are accepting the alternative hypothesis. But in statistics, that statement we don't say. Instead of saying accept the alternative hypothesis, we want you to say reject the null hypothesis, because the decision is on the null hypothesis. Okay, come and look at the second rule. The second decision rule says that if the calculated chi-square is less than or equal to the critical value, fail to reject. Now, you see, failing to reject is also the same as accepting the null hypothesis. So what we are saying is that if you calculate and then the calculated R squared, okay, is also less than this, fail to reject the null hypothesis. That is what has been written over here. You fail to reject. If the calculated R squared is less than or equal to the critical value, fail to reject. Failing to reject the null hypothesis is more like, see, fail to reject the null hypothesis. It means accept the null hypothesis. But in statistics, we don't want you to use the statement accept the null hypothesis. We want you to use fail to reject. That's the meaning. Is that okay? So if the calculated R squared is less than, now let's check. In this situation, see our calculated R squared is 0.80. See our critical value, 3.84. You can see this calculated R squared is less than the critical value. In such a situation, you fail to reject the null hypothesis. So here in this very calculation, we will fail to reject. So see, 0.80 is less than 3.84. So we fail to reject the null hypothesis, meaning that if we fail to reject the null hypothesis, what it means is that we've accepted the null hypothesis, and therefore, what does the null hypothesis state? It states that there is no relationship between two variables. Is that okay? So in this situation, our conclusion will be that we fail to reject the null hypothesis. And that will take us to step 8, where we will state the conclusion. And you are going to write, since the computed or the calculated chi-square, which is 0.80, is less than the critical value, which is 3.84, we fail to reject the null hypothesis. Therefore, there is no significant relationship between exercise habits and blood pressure status among the adults studied. Simple as that. Is that okay? All right, so this brings us to the end of our second example, chi-square test, hypothesis testing. All the best. Catch you in the next video. Do well to subscribe to this channel Share the content on this channel to your friends who are studying statistics, especially those doing inferential statistics. I wish you all the best. Bye-bye.